First, we need to study the 8085 microprocessor what specification. So 8085 microprocessor have 16 address lines. That is, it can support up to
2 power 16.
2 power 16 the memory location. Okay, nothing but approximately you can call what 64 kilo. Okay, memory location 64 kilo memory can support all bytes. Maximum it can support 64 kilo support on it. 8085 microprocessor have 8 data lines on. Data lines are different, address lines are different. No relation. No relation. Address lines are decide the depth of the memory height decide. Okay. So data lines are decide the processor capability. Okay. The processor the capability decide on it. That is, it can call 8-bit the microprocessor. Okay, you can also pronounce like a power of the processor. Okay, power, the processor power, you can measure the data lines on it. Yeah, power of the processor. Power nothing but not a power supply. No, there is meaning capability. Okay, power of the processor on it. So the processor power, you can decide the number of data lines on it. Okay. So number of data lines are increasing, processor capability increasing. I don't know the courier boy come into the bike. Okay, small the item. Okay, 8-bit. Courier boy come to your house is a the minivan, 16-bit. Correct? No, the item or the what is the item come to your house now through the road. Okay, that is data lines on it. Okay, small item is a definitely 8-bit. So highway is a very bigger van. Okay, 16-bit, 32-bit like that. More. Okay, vehicle. Okay, item is more. So like that, how much road is a more and item definitely the more number of data you can transfer now. Okay. So 8085 microprocessor, it have 40 pin IC. The 40 pins are there. 40 pin IC made of NMOS technology. NMOS is a logic family. Okay. So finally, your logic circuit converted to NAND or NOR gate only. After manufacturing is the logic family. N-type metal oxide semiconductor. Okay, NMOS technology now the manufacturer only. So it's made of the NMOS technology only. Nowadays, everyone knows the CMOS technology. So that is a NMOS now, the 8085 microprocessor only. How many number of pins now? 40 pin IC now. Okay, every IC now is the integrated circuit now. Okay, now latest IC also some number of pins are there on. Okay, number of pins on. 8085 microprocessor, it requires 5 volts power supply and frequency also, and operate 3.01 megahertz clock frequency. So nowadays the microprocessor operate the gigahertz only, 2.4 giga, 3 giga speed on nowadays. The old processor no, it can support the how much speed no? Mega 3.01 megahertz no the clock speed on. Okay. So every microprocessor IC contain the crystal oscillator pins are there. Crystal oscillator. So microprocessor is a digital circuit, is an internal sequential combination together. Wherever the sequential nothing but clock is a mandatory. But what the source of the clock? The clock source is a oscillator. What is clock source? Oscillator. Source no. Who provide the clock? Oscillator. So RC crystal oscillator very popular. Everyone using also. RC crystal oscillator. So yeah, crystal oscillator 2 pins are there. X1 and X2. 2 pins are there. The oscillator on the crystal oscillator size is a 0.144 megahertz on it. 6.144 megahertz. The crystal oscillator size on size.
Could you please explain once again on oscillator?
Yeah. Actually, the microprocessor contain the combination and sequential. Okay. sequential digital circuit need clock pulse only. Okay, sequential digital circuit output changes whenever apply the clock. Okay, why clock? Timing manner. Because internally contain so many circuits now. Okay, one circuit to other circuit timing manner important. Okay, for example, we are execute the now we are study the assembly instruction move a comma b. First instruction, first stage is fetch. What second stage? What? Decode. So your timing important. First fetch happen, then one next start tell me decode. So the fetch how much time execution. Okay, timing manner important. Okay, the synchronization important here. Okay, no, the instruction execution, so many steps are there. Yesterday also discussing how to perform memory read operation. Okay, steps are there. First step is find out the memory location through address line. Okay, it takes some time, no, the find out, no. First step that one, the first timing manner. Whenever that is over within the time period, next time start only. So the synchronization is there. Okay, so the order follow exactly. That's why timing manner is very important. Okay, the timing who provide is the source of the clock. No, clock is a timing manner. Okay, clock source what? Tell me. Oscillator. Oscillator. Oscillator is a source of the clock. Okay, there no oscillator, we don't have the clock. Okay, so that's why every microprocessor people observe either microprocessor, microcontroller. You can see the any PCB board now. You can observe oscillator compulsor is there. You look like some silver model color, correct? No, small one is there only. Okay, cylindric model, or no, the rectangular model is there. No, crystal oscillator, no, small model. Okay, the crystal that is called what? RC crystal. Okay, so what is the RC crystal size here? 6.14 megahertz. The processor maximum support how much is a 3.01 megahertz. So it can support 3.01 megahertz. Okay, but who provide nothing but this one outside. So what happened? Here you can see now. So requirement is what? Requirement is of the frequency works what? 3.01 megahertz now. But crystal available what? 6.141. So we need a on-chip clock divider circuit. On-chip clock division by 2 circuit is there on 6.114 by 2 nothing but what? 3.01. Why clock divider circuit nothing but? So this requirement exactly crystal is not available. That's the reason actually we need to divide the by 2 and now. Okay, exactly. So maybe that's why you study a clock divider circuit now. So you should know the the T flip-flop, yeah. The T flip-flop output is equivalent to half of the input frequency, half of the clock divider. T flip-flop is studied no digital circuit no. The same no. Okay, half of the circuit on clock divider. Counter also can useful also. Counter also frequency division circuits on. 8085 microprocessor have on-chip clock generation facility. On-chip clock generation facility. The on-chip clock generation. This circuit generate the clock only. Your requirement clock this one only. Okay. So frequency 3.01 megahertz. Then you can time also can find out also. Time is a 1 by f is approximately 0.33 microsecond only. 0.33 microsecond. In 8085 microprocessor, one time period, one clock pulse is 0.33 microsecond. 8085 microprocessor have 6 8-bit general purpose registers are there on GPR, nothing but general purpose registers. 8085 microprocessor have 6 8-bit general purpose registers are there. Those are, B, C, D, E, and what? H and L. B is a 8-bit register. Okay. B 8-bit register. Okay. B is a 8-bit register. C also 8-bit register. D also 8-bit register. E also 8-bit register. H also 8-bit register. L also 8-bit register. Okay. So 6 now. 6 are there only. We are called a general purpose register. The meaning of general purpose, we can use any purpose like that. Like this register, we can store a data. Okay, like some kind of programmer, no? Some data we can store. This register we can store address also. The memory what? Memory address also can store. You know, the memory, memory contain the location. Each location contain what? Tell me, some address. Every address inside contain the what? Data. The data now. Data is what? Tell me, this is what? Address. The data. So a lot of difference is there, the meaning of address and data. So memory inside contain the data. Okay. Yeah. Maybe memory inside contain the data, sometime address also. That is called pointer concept actually. That also contain what? Address also. So if you are going to read the content of the memory, or we are going to read the content of the register. Memory nothing but what? Register. Understood? No? We are going to read the content of the memory, not the register. First of all, you should know address or not. Okay, address is different. The address inside is the maybe data also. Okay, generally memory contain the data or program. So the data also, the program also. Example, program move instruction. Data also it contain on. Okay. So this BCD we can store either data also, program also, either address also. Anything you can store. That's why called what? General purpose. Anything we can use. No, not a particular thing. Okay. Understood? No. 8085 microprocessor support register pair also. Register pair example, BC pair, what? DE pair and what? HL pair. 16-bit. They are what? Only B what? 8-bit. Only C what? 8-bit. The meaning of register pair, combination of two registers only. Combination of two registers. Then B868. Combination what happened? 16-bit register. D and E combination what? 16-bit. H and L combination what? 16-bit. Programmer, you can know the 16-bit register also. 16-bit register. But no straightforward 16-bit general purpose register only. Understood? No. You can know the combination of what? BC. Combination of what? DE. Combination of HL. But we can't do the BE combination. Not possible. Because these are one row. Understood? No? The B8, C8, the one row is there. Okay. This way, not combination. BE combination not possible. Understood or not? 16-bit combination only for possible what? BC or DE and HL. We can't do the CD. We can't do the HL. The combinations are not possible. Cross combination. Only for the three combinations. Whenever programmer to use a 16-bit general purpose, you can go BC, DE, HL. Only 8-bit is 6 are there only. And one more thing also. 80 microprocessor have two 16-bit registers. Two 16-bit register. They are special purpose registers only. Okay. Two 16-bit registers. They are 16-bit, not a general purpose only. Special purpose. General purpose, but anything you can store, no matter. A special purpose. One is called a program counter. Other one is called, tell me, stack pointer. Okay. Program counter, stack pointer. 8086 onward, it is also called instruction pointer, IP. Program counter, PC, stack pointer, SP. So 8085 microprocessor have two special purpose register. Special purpose register, not a general purpose. So what is the meaning of special purpose? The name clearly, program counter. I think the memory contain the, I told, data also and what? Program also. For example, this address, my assumption 2000 is address only now. The memory 2000 address now. The address here contain the some program is there. Some program is there. Okay. Memory contain the program. What a program? Move instruction, something. Okay. Some program is there only. So microprocessor responsibility to load the program or not? Microprocessor, what is microprocessor goal? Execution of a program. But where the program located? Memory. So microprocessor responsibility, communicate the memory, load the program. So microprocessor communicate the memory, load the program, but microprocessor should know where the program locating or not. That address now given to who? Which register? Program counter. The program counter, it can hold the address of the instruction. Hold the address of the instruction. Where are the program in the RAM? That address hold the program counter. So generally you can tell about program counter hold the address of the next instruction. Because program counter keep on incrementing actually. That's why you can pronounce like that only. Hold the address of the what? Next instruction. Next instruction. Okay. Program count hold the address of the next instruction. For example, program count 2000 hold whenever 2000 here one instruction execution, it can automatically hold the next instruction address on next one. This one completing next one. Like that, program counter keep on hold the next instruction, next one. Your program, how your program run now? First line number 1. Next what? Line number what? 2. Your program line by line running. If you write the C program language or any language, write the program line by line. How your program run one by one? Because of which one? Which one takes the responsibility? Program counter. It's very important. So tomorrow we are going, that is the actual assembly language program important here, okay? Where people are tomorrow debug the code, okay? Hardware, write the code, debugging, okay? But you should know exactly where the program stop, okay? The exactly where the program stop, who can identify? Program counter. Exactly where the bug in the code, okay? Now program count identify the line is the bug is there only. That line you can go and fix the bug only. Okay, understood? Your program software, the program any bug, no? Program count exactly the program. You have some 100 lines are there. So the line is some bug is there only. So now program counter, wherever the bug in the line, that address program counter hold on that address now. Okay, where the exactly the program is stuck up here only, hang up. The address load also. Now we need to go that area and the line number, what is the bug in the code, understand, try and fix it now. Okay, it's very important program counter. So ultimately program counter hold the address only, the memory address, not the data. Memory address no, just the address of the memory, not the data. That's for special purpose only. And stack pointer. Okay, memory contain the program, just now I told. And memory also contain the data also. The data also contain the address. Okay, address, okay. So now write a program, load the data. Earlier what? Load the what? Program. Now you what? Load the what? Data. Program different, data different. So program identification point of which one? Program counter. Data loading point of which one using? Stack pointer. Which one? Stack pointer. Stack pointer. Stack pointer hold the address of the top of the stack. The stack contain the data. Okay, not like a program. Data. Programmer data, local variables. Not a global only, local variables are there. Okay. Tomorrow write the C programming. Okay. Now the local and global we see. Okay. Stack pointer is hold the address of the top of the stack. Stack nothing but temporary data. Top of the stack. Top of the stack now. Stack is a temporary. Only stack is a word indication, temporary memory. The temporary memory is nothing but the local variables. Stack is a word. It's a temporary memory. Stack pointer, it can hold the address of the top of the stack. Okay. The two registers are very, very important. Okay. Program count and what? Stack pointer. The two are special purpose register. The very simple concept now, the memory contain the program also and what? Data also. So the microprocessor, how to understand the program or data is the communicate the program, you can go via what? PC, program counter. To communicate the data via what? Stack pointer. That's why very, very important. So now I will show the very clearly exactly program counter, stack pointer examples. Now we are going to discuss more clearly in the coming. Okay, some assembly instruction explain clearly. Example, call instruction, jump instruction, stack pointer, push, pop. The very beautiful instructions actually. We are explain clearly what is stack pointer, what is the program counter. We'll discuss more clearly. It's only the summary one I'm telling. Yeah, just to idea what is what. Understood now? So 8085 microprocessor have one more also. 8-bit process control register. Process status register. Process status register. Is also called one more name also. Accumulator. Accumulator A register. The name of the register is A only. A. The register name is A. Okay. don't call the general purpose register. Okay, it's simply called the 8-bit process status register. Okay. So 8-bit register only, 8-bit. Yeah. 8-bit, like a BCD like that only, but it's separate category. Okay. A pair not possible, like a BC pair, nothing. A separate register, no, 8-bit register, no, separate one. Separate register, no, 8-bit. So why separate one? Accumulator? Accumulator, it can store the recent result of the, the system, recent result. So the recent result, okay, the just know what happened the processor, no, just know last result, where you can find out. Accumulator. That's why kind of process status, no, status of the system, your computer, no, the current status now. Okay, BCD what? General purpose. Okay, the recent result, no, you can store. I think that people know also. ALU, you know, ALU. So whenever ALU after perform arithmetical logical operation, okay, the result where you can store, tell me, where you can store? Accumulator. So accumulator, it can store the result of what? Tell me, ALU. Okay, now understood now? You can perform any arithmetical operation. Okay, finally see the result where? Accumulator. Accumulator, it can store the result of the ALU, arithmetical logical operation. So input is you can give the register, okay, A or B, the register give it also. Okay, for example, add B instruction is there only. Add B. What add B? B value add with the what? Accumulator, where the result store? A. Add B. After addition, the result compulsory where? A. B is the operand, the B is the value added to the what? Accumulator, where the result store? Accumulator. So by default, result where can come in? Accumulator. Okay, addition, subtraction, arithmetical operation, logical end, logical or, so everything. Okay? After any ALU operation, okay, the result where you can see? Accumulator. You understood now? Hello? Yes or no?
Yes, sir.
Okay, online people are following now? Hello?
Yes, sir.
Sir, is it temporary storage?
Yes, sir.
Yeah, tell me.
Sir, I have a question. Is it temporary storage?
Pardon? This one?
Yes, yes.
Yeah,
Accumulator.
temporary like that. Temporary, okay? Temporary like that. If you want override, the information gone only. Okay, after add B, the result where you can store A. Okay, the A is the temporary, okay? Until unless override the value is available. Okay, next instruction override now is gone only. Okay, next instruction override now is gone. Otherwise, the value should be there. Okay, so understood everyone? The default result only. The after any arithmetical logical default result, where you can check it now? Accumulator. Okay, and one more also there one very important. Okay, so after ALU operation, the result you can check the accumulator, and after ALU operation, one more result is also coming. Okay, so that is called a flag register. One more is also there, flag register. It's very important register. So once ALU operation perform, depending on the result, flags are affecting only. Okay, flag, okay, carry flag, zero flag, sign flag, flags are affecting only. The flag indication, like the result is a 0, result non-zero, okay, comparison like that, useful on flag register. It's very important, flag register. So what happened? Tell me one more point also. 8085 microprocessor have 8-bit flag register. Every microprocessor flag register compulsory now. Every microprocessor like a accumulator type of register compulsory now. Okay, flag register only. See the total 5 flags are there. X indicate unused bits only. Unused bits. They are unused bits only. X nothing but unused. In future purpose. First one which flag? Tell me. Carry. I think every bit you know the flip-flop or not? Every bit is what? Tell me. Flip-flop. On and off only. Flag nothing but on or off. Just the flip-flop only. Every flag is on and off on now. Every bit now. So here total 8 bits nothing but 8 flags are possible, but here support the only 5 flags only. Okay, remaining fifth position, third and one is a unused bits only. How many flags are there?
5 flags.
Have 8-bit flag register. It contains how many flags now? 5 flags. Those are 5 flags. Okay, first one. First flag is a, for example, no, the sign flag only, sign flag, MSB. Sign flag, what bit position? Which position? 7. Sign flag, okay. So 7th bit position, any flag is a, 2 things are there, either on or, tell me, off. 2 things are there. So 0 is there, MSB 0, the sign flag, no, everyone. Sign flag MSB 0, positive or negative number? Which number? Positive sign or negative sign?
Positive.
MSB 1 is the which sign?
Negative.
So whenever sign flag equal to this sign flag equal to 0, the number is what? Positive. A sign flag equal to 1, the number is what? Negative. If you understand now. After perform addition, this MS bit position only. This bit position is a 0 is a positive number. Your 1 is what? Tell me. Negative number only. Okay. Now affect the result on now. Okay. Sign flag only. Okay. Next one. 0 flag. ZF. The bit position what? 6. 0 flag equivalent to 0. The meaning, no, the 0 flag equal to 0. After subtracting the 2 numbers, any 2 numbers subtracting, like a 5 minus 5 subtract only. What the result? Tell me. 0. After subtract the 2 numbers, the result is a 0. The result is a 0. That is called, then the 0 flag equal to 1. 0 flag equal to what? Tell me. 1. Whenever after subtracting the result equivalent to 0, tell me the result equivalent to 0, then ZF equal to what? Tell me. 1. So ZF equal to 1, nothing but just now the subtraction happened. What the result? Tell me. 0. What the result? Tell me. 0. For example, subtracting 5 minus 4. What the result? Tell me. 1. This is called a not equivalent to the result not equivalent to 0. Result not equivalent to 0, nothing but any positive number, any number, negative or positive number. Result not equivalent to 0. Some number is there only. Then ZF equal to what? Tell me. What is the ZF file? Tell me. 0. Okay. 0 flag, 0 or 1. Decide the result. Decide the what? Result. Every flag decide the ALU result only. After addition or subtraction result only. After subtraction, the result is a 0. 0 flag equal to what? Tell me. 1. After subtraction result is a non-zero. Then 0 flag equal to tell me 0. What the next one? Auxiliary carry. Auxiliary carry. Is a normal carry and a auxiliary carry. What auxiliary carry position? Tell me. 4th. So auxiliary carry is a nibble position. Nibble. So whenever the carry generate the nibble position, you can call what? Auxiliary carry. 4th position only. Nibble. So carry generate the 4th bit position. Nibble position. Nibble. Carry generated only. Carry not generated only. Okay. 4th bit position, carry generated only. So no carry. 4th bit position, the no carry. So 4th bit position, no carry. No carry, then what happened? 0. Okay. AC equivalent to 0, nothing but 4th bit position, no carry. AC equivalent to 1, nothing but, tell me, 4th bit position what? Carry. 4th bit position. After addition. After what? Addition. Nibble position. Okay. Next to
Sir, can you explain this again? What is this carry?
After addition, carry generated, no, generally no. After addition, okay, we are going to add the binary numbers, no. So general, any carry generated, no. The carry is a 4th bit position, no. That called what? AC.
Okay, understood.
Carry 8-bit position, tell me. CF. 8-bit position, okay. Where carry the position number, no? Position, exactly. That CY, tell me. CY is a bit 0. Okay. Carry 8-bit position. Here 8-bit position. 8-bit position. 8-bit position. 8-bit position carry generated is a 1 only. Carry not generated is a 0 only. CF. The parity flag true or false. Tell me, this is the number of ones. Okay. In the result, count the number of ones also. Count number of ones only. Count. So number of ones are odd is coming. PF equal to what? 1. Number of one even is coming. P of equal to what? Tell me 0. Okay, even number is a even number is a 1 only. Odd number is tell me 0. Yeah, correct. Even is a 1. Odd is tell me 0. Correct. After addition or subtraction, whatever, any ALU operation, the result, where the result tell me? Accumulator. The result verify. Count how many number of ones only. Count. Understood now? That depends on changing also. So the flag register is the result. Understood now? Is the result now. For example, here A value is a 5. B value equal to what? 3. A value 5, B value what? Tell me? 3. You can perform addition. You can perform addition. You can perform addition. Okay. The ALU input what? A and B. Perform the input now. Is output now. Perform addition. 1 plus 1, 0, 1. 1 plus 1, 0, 1. 1 plus 1 what? 0, 1. Next what? Tell me. 1. Next to 0, 0, 0. This result where you can see. 1 plus 1, 1, 0. 1 plus 1, 1, 0. Okay. Correct now? That okay. This is where you can see. Where you can see the result now.
SSC. Accumulator.
Accumulator. So ALU input what? A and what? B. After ALU, the result where you can see accumulator. And also the result where you can also check it now. Flag. Flag now. 1, 2, 3, 4, 5, 6, 8. Okay. What a position of the standard position of flag now. So first position is a see. Fifth, third, one, no, 5, 3, 1 is the unusual bits only. Seventh bit, what type of the flag? Sign flag. Check it now. MSB. MSB positive or negative? Positive. Sign flag equal to what? 0. Sign flag what? Tell me. 0. 0. This is all the result now. All the result. Depending on the answer now, the result changes now. Sign flag. Next one, tell me. Next flag, tell me. Sign flag. 0 flag. The result equal to result not equivalent to 0. Result not equivalent to 0. 0 flag equal to what? 0 flag, tell me. 0. See the result not equivalent to 0 or not? No? Result what? Result not equivalent to what? 0. Result not equivalent to 0 is a 0. Okay. So some positive integer number is there. Okay. So the fact is 0 flag equal to 0 only. Fourth one. What is fourth one? Fourth bit position. Okay. 0, 1, 2, 3. The fourth bit position actually. Fourth bit position. 0 plus 1. What happened? 0, 1. No carry or not? No. In the fourth bit position. In the fourth bit position, no carry. Okay. What happened? 0. 0. And second bit. What is second bit position? Parity. Tell me. Count number of ones in the result. Count number of ones. Tell me. How many ones are there? 1. Odd number or even number? Odd number. Odd number. What is the value? Tell me. 0.
0.
0. Last 0. 0 bit. What last 0 bit? Tell me. Carry flag. Carry. So carry is the year. 8th bit position. 8th bit position. No carry na. So tell me what answer. Tell me. 0. 0. So all the flags now 0. Depends on the result. Depends on the result. You understood or not? Flag register also result now. Okay. Accumulator contain actual data, but flag contain the status of the system. Okay. No, the just now what kind of flags affected? No, the information there on. Okay. So flag register is affected only after performing the ALU operation. ALU. Okay. Arithmetical and logical. Any logic gate also, any logical operation also, it's affect now flag register. The flag register is very important actually because the content of the flag register programmer decide. Compare the two numbers. Comparison of two numbers. The numbers are equivalent, numbers are less than. Where people write the C programming language, control statements on. Okay. Comparison. Okay. Comparison very helpful actually. This one. And 8085 microprocessor have the 16-bit process status word. We call it PSW. Process status what? What? PSW. Process status what? Okay. Have 16-bit process status what? PSW. The meaning of process status word is nothing but accumulator plus tell me flag register. Accumulator is 8-bit. Flag register tell me 8-bit. So they no separate PSW register. They no separate one only. Okay, now the A plus flag register no, the combination pronounced like a PSW. Okay, they no separate PSW register now. They both now 8 plus 8 16-bit register. 8 plus 8 what? 16-bit register. So the name clear. Program no process no not process. Program status word actually not process. Program. Change it now. Program status word PSW. So the meaning of program status word, we have program status now. We have some program in there, the status now. For example, the line number status you need. Any line number, the status now. The status is the recent result. Recent what? Result. The recent result where you can find out now. Accumulator and what? Flag register. Okay, that's program status what? Word. 8085 microprocessor. Any microprocessor have compulsory interrupts on. Definitely. 8085 microprocessor also interrupts are there. Okay. Basically, interrupts are two types. Okay. So generally, we have interrupts are two categories. One category is a software interrupt. Second category is what? Tell me. Hardware interrupt. Two type of interrupts on it. Software interrupt, hardware interrupt. Software, hardware. Software interrupt is like a synchronous interrupt. Okay, it's also pronounced like a synchronous interrupt. Synchronous interrupt. You can also call it software interrupt. Synchronous. The meaning of synchronous, programmer generate the interrupt. Programmer know exactly what time interrupt occur also. So programmer generate the interrupt is called what? Programmer to generate the interrupt is called what? Software interrupt. So we have the program is there. Okay. For example, line number 10. Line number 10, you programmer write the line. Okay. Programmer write the line to generate the interrupt. Programmer decide. Program run line by line. Programmer decide. Line number 10 interrupt occur. Programmer you decide. At programmer writing time you decide that the line interrupt occur only. That's why programmer decide that is synchronous. You decide exactly what time interrupt occur only. You decide the program sequence order. Okay. That's why you can call what? Tell me. Synchronous. The program flow decide. The program sequence decide now. Okay. For example, best software interrupt is a programmer by mistake. You are execute the divide by 0. Divide by what? 0. Programmer, no, line number 10 divide by 0. So divide by 0, computer cannot understand. No? Divide by 0 is what? Infinite. Yes or no? So then microprocessor go to interrupt handler. Okay, because cannot do exception. Okay, cannot go to interrupt handler. The divide by 0 is the best example of software interrupt. No? It's got software interrupt. The programmer line number 10 generating only. Program run the line by line, but programmer mistake only. But whatever, but line number 10 programmer because of the divide by 0, because the programmer write on by divide by 0, what interrupt occur? That called what? Software interrupt. Programmer generating interrupt only. Hardware interrupts are we can simply call it asynchronous interrupt. Which interrupts now? Asynchronous interrupt. Asynchronous interrupt nothing but unexpected interrupts on unexpectedly. The interrupt is occur any moment. Okay, unexpectedly happen or not. So device generate the interrupt. Hardware device generate the interrupt. Hardware no, not the programmer here. Device. The meaning of hardware interrupt. Every hardware interrupt physically existing only. You can see physically the hardware interrupt now. Software interrupt you can't able to see now. Physically existing on the your hardware. Okay. Physically. Okay. See, no, the is a IC now. So 40 pins are there. No. One of the 40 pin, one pin is a hardware interrupt. So this pin is what called? Tell me. Hardware interrupt. Physically what existing. Where people are human can see the physically the available. Okay. No, the hardware interrupts are you can see the pin number. Okay. This pin acting as interrupt now. Software interrupt we can't see. So because programmer only internally what generating. Understood no? Hardware is a physically no. For is a device no. Some device is the keyboard is a device now. The device is a you press the key. It can write the interrupt to the microprocessor or not. through physical, you can see some kind of connection, the physically through some wire. Okay, so once you are press the keypad, the keyboard generate interrupt to what? Microprocessor. Through via what? Some pin. Yes or no? The physically the existing interrupts are called, tell me, also hardware interrupt. The interrupts are who can generate? Device. Some device generating now. Okay, you are press the keypad, some generating also. So the interrupt is happen physically. That is generally in the form of, is called triggering. What I mean? Trigger. Okay, the meaning of triggering is rising or, tell me, falling. Rising or what? Falling. For example, whenever the default value 0, suddenly the interrupt occur, it go to what? 0 to what? Tell me, 1. Kind of rising type of what? Interrupt. Okay, edge trigger, the rising type of interrupt. Otherwise default value 1 only. Suddenly interrupt occur, tell me, falling. Okay, so the voltage levels not suddenly up and down. Okay, so rising interrupt or what? Falling interrupt. Triggering. Okay, physically you can see now. We have logic analyzer, multimeter. Logic analyzer, so the demonstration. Okay, logic analyzer or the multimeter, or maybe your oscilloscope best one. Okay, connect now. You can see now triggering now. The supply now happen. Okay, whenever you go to trigger now, that time what? Interrupt what? Occur. Okay, so the hardware is a type of trigger now. Okay, understanding. So in 8085 microprocessor, 5 hardware interrupts are there only. 5 hardware interrupts. So n number of hardware interrupts are there, n number of pins only. Yes or no? How many hardware interrupts are there? 5. How many pins are there? Hardware interrupt. How many pins are there? 5. Out of 40 pins, 5 pins are what? Tell me. Hardware interrupts. Physical existing one. Out of 40 pin, 5 is the hardware interrupts one now. So the 5 hardware interrupts now, the name is there now. First interrupt name is a pronounced like a trap. Second one is a called a RST 7.5. Next one is a called a RST 6.5. Next one is called a RST 5.5. So next one is called a INTR. Trap is also called a RST 4.5. Okay, they are the interrupts now. Okay, all direction input only. Direction what? Input on now. All direction. So 8085 microprocessor have the 5 hardware interrupts only. 1, 2, 3, 4, 5. .8085 microprocessor have 8 software interrupts only. 8. Software interrupt nothing but programmer execute. Nothing but through instruction. Through what? Instruction. Program nothing but through assembly instruction. Okay. So what are assembly instruction is it? RST. What assembly instruction? Tell me. RST.
Reset.
Okay. RST space, tell me. N. N. Where N is what? Where is N is what? Tell me. 0 to, tell me, 7. Where N is what? 0 to what? Tell me. 7. RST. RST we can also call a restart. General RST. RST is a software interrupt. N nothing but 0 to 7. How many software interrupts are there? 8. RST 0, first software interrupt. RST 1, second software interrupt. RST 2, third one. Like that, how many are there? 8. Assembly instructions are there, 8. So any microprocessor definitely have the understand interrupt compulsory. Okay, the 2 type of, okay, hardware interrupt and what? Software interrupt. 8085 point of this story. Fine. So interrupts also priority is there. Priority we will discuss now. The priority is there. So because why priority? What is the reason of priority?
Which needs to be executed first.
2 device rising interrupt at the same time. You can go to what time next level? Priority. Correct? The device 1, device 2. Okay. The both are rising the same interrupt now. Okay. So microprocessor question mark. Which one to handle? At the same time, 2 interrupt occur. So now here the specification of 8085 microprocessor now. So we are understanding the whole concept of it.